Welcome to my channel. Your tutor Mariam is here. It's the 11th video of Introductory Physics 1 and the 7th video that I'm going to talk about the motion, which is the second subject of Introductory Physics 1. In this video, I'm going to talk about the fault-free acceleration. What is a fault-free acceleration and what is the difference of moving the object in x and y axis in terms of the equation of motion. And at the end, I'm gonna solve a couple of problems for you. So if you are new to Introductory Physics 1 and would like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So the first question is, what is the fault-free acceleration? Fault-free acceleration is the acceleration in y-axis. Is always 9.8 meter per second square, approximately 10 meter per second square, and the symbol is g. Okay, and then let me explain it more. For example, I have a ball, car, and pen. They have a different mass, right? I'm gonna drop them at the same time, right? If I ask you what is the acceleration, you might say they have a different acceleration because they have a different mass, right? The answer is no. They all have the same acceleration, which is 9.8. And this is 9.8 comes from the Earth gravity. So it's not going to change at all. It's always 9.8. So the fault-free acceleration is independent of mass, density, and shape of the object, okay? So it doesn't matter if car is heavier, pen is lighter, it doesn't matter at all. They all have the same acceleration. Now, let's see what is the difference if I move the object in x-axis and y-axis. I have a car, I'm going to move it in the x-axis, right? How about if I have a ball and toss it upward? Okay, now I'm moving in the y-axis. So if I move the object in x-axis, I must know the acceleration, which show as a, right? So I can calculate it in a different way for the acceleration by moving the object in x-axis. But for y-axis, like drop the ball, toss it upward, I know the acceleration is 9.8, approximately 10 meter per second square. And as an instructor, we expect you guys know this. So sometimes in the exam, this fall acceleration not gonna show up in your equation sheet because we expect you guys know g is equal to 9.8. But for the moving the object in x-axis, you should have some known parameters that you can calculate the acceleration, or it's gonna given to you. Okay, now let's look at the equation of motion in x and y axis. So in x axis, as I said, you don't know what's the acceleration. You might have to find it, or it's given to you. Okay, so in x axis, the coordinate gonna be x, right? So it's gonna be x, the displacement gonna show as a x, and the acceleration gonna be a. So right here, and then right here in equation 1, right? And the same for the other equations. However, in y-axis, fault-free acceleration is g, right? And then it's always going to be 9.8 meter per second square, right? And then the displacement going to show up as y because we drop the object or toss it upward in a y-axis, right? And then acceleration is gonna be g, right? Which called as a fall-free acceleration. So technically speaking, the equations you see in the left side and right side are similar, or I have to say they are the same. The only things is changed is y-axis, like x changed to y, and a changed to g. Okay, now let's look at the complicated example. So imagine I have a ball and I'm going to toss it this way, right? So I can tell this is only in y-axis or only in x-axis. Why? Because if you look at the motion of this ball, you're going to see this ball is like moving in x direction and also y direction, right? So I have both axes here. In this case, if I'm going to write down the equation of motion, I should consider both, right? So I can have the x and y axis. It depends what problem asks me, right? Or what I'm looking for. Now let's look at the example. So in question 1, a car has a speed of 60 meter and the acceleration is 10 meter per second square, right? So it asked me how long does the car take if the driver hit the brake and stop the car, right? Let's solve it together. So here I'm gonna work with the equation 4 here that I mentioned in the previous slide. And the reason I'm gonna choose it is because I only have the acceleration and speed, right? That's the reason I'm gonna work with equation 4. So if you don't know how to choose the equation and why I'm gonna choose this equation, you can watch the previous video. I explain all this equation and where we should use this equation. I'm gonna put the link below and also on top of this video. So here, the speed, the initial speed is 60 meter per second, right? And then the acceleration is 10 meter per second square, correct? And take how long it's gonna take. So I don't know t. T is my unknown parameter. But also is asked about is a stop, right? What that means, if something stop and is not moving anymore, that means my V1 gonna be 0, right? Because it's a stop, it's not moving anymore, correct? So now I have 3 noun parameter and 1 unknown parameter, which is t, right? So in terms of equation 4, V is equal to AT plus V naught, right? So my V is going to be 0. Acceleration is 10, right? I don't know about t. And then the initial velocity is going to be 60, right? I'm going to solve it in the way it is, and I'm going to explain what happens. So if I solve this, my t gonna be minus 6, right? Second. I'm going to write it down as a second, and you will see what's wrong. Do you find anything wrong here? Just pause the video and think about it. My t is minus 6 seconds. So the minus, the negative time is totally wrong, right? We can travel past, right? So minus 6 doesn't make sense. What I did wrong here is about the acceleration. So sometimes you find it in your textbook, exams, homework. The problem tell you the acceleration is positive, right? So A is 10. But technically speaking, is not positive, because think about it. I have a car, I'm driving the car, and I stop, right? Acceleration drop. It doesn't increase. If I put it as a positive, that means my acceleration increase. But in this case, if I stop the car, acceleration is negative, right? So here, I'm going to say correction. I'm going to write it down again. It's going to be 0 minus 10t plus 60, right? And then if I solve this one, it's going to be 6 seconds, right? It's positive and it's totally realistic, right? Now let's look at the other problems. So here I have a boy. A boy tossed a baseball up with the initial speed of 60 meters per second. How long does the ball take to reach the maximum height? Right? So let me write down the noun parameters here. I have a speed which is equal to 60 meters per second, right? And then it asks me how long it's gonna take, t, right? And then looks like that's all I have, right? So what I want you guys notice, I have two other known parameters here. Let's talk about the maximum height here, right? Of course, I don't know about height. I have no knowledge about it, but maximum height means this is initial velocity. My maximum height is gonna be tell me that v is equal to 0. Why? Imagine I have a ball, right? I'm gonna toss it up, right? It's gonna to the maximum point, right? What's gonna happen at the end? It's gonna come back, right? So at the maximum height, my v is equal to 0. That's why I said that, because when it's reached to the maximum height, of course, because of the gravity, this object gonna come back to the earth, right? So the v gonna be 0, and at that point, the object gonna come back to the earth, right? Also, I know g, the acceleration, is equal to 9.8 or approximately 10 meter per second square. Okay, so now I have 3 noun parameters, right, and 1 unknown parameters. Again, I'm going to use equation 4, which is v equal to gt plus v0, yg, because we're talking about the y-axis, right? So if you look at this problem, you see it doesn't mention about the acceleration, because it's expect you guys know when we talk about the y-axis, we're not talking about the normal acceleration, we're talking about the fall-free acceleration, g, and g is equal to 9.8. You should know, okay? So now let's substitute the parameter. So my v is equal to 0, g is 9.8. Since the direction is negative, is always minus 9.8. I'm going to consider it as a 10 approximately, okay? And then t, and then my v gonna be 60, right? So t equal to 6 seconds, right? So both of these questions, question 1 and 2, are similar, right? The difference between these two, the first problem, I solve it in the x-axis. I must know the acceleration, right? For the question 2, I drop the ball, right, or a boy toss it up, and then I should know the acceleration is 9.8 or 10 meter per second square, and then find the time, right? I hope with this two example and this basic concept, you understand the difference between the equation of the motion in x and y axis and what is the fall-free acceleration. So if you like my video, please hit the like button and I'll see you in the next video.